Welcome back. We're going to continue our discussion on organic chemical reactions. Now, this is probably going to be the longest phase of this whole course. Okay, so there's going to be a series of videos which will be broken and grouped together based on the type of reaction that will be carried out. So before we understand all that, it's very important we understand this very basic concept as we move forward. Okay, so this particular video is going to be short and crisp because I only want to emphasize this particular concept because I don't want it to get diluted among other things that, and if you graduate from my class and you don't know this information, then it just doesn't look very good. So without further delay, let's get started. Okay. So the basics. You cannot forget everything we have learned until now. This is all built on the knowledge you have learned up until this point. And the one basic thing you will not ever forget after you get out of an organic class is carbon must have 4 bonds. Yes, there is one cation that has 5 bonds, but 99.999% of the time, carbon must have 4 bonds, and that's what we have learned, and that's what we are going to stick to. We're going to add one more piece of information to that because I think that's vital, and because that contributes a lot to how the molecule is stable or not. Okay, carbon bonding can be primary, secondary, or tertiary. Okay, now this idea of primary, secondary, and tertiary only extends to carbon containing 4 single bonds. Okay, that is, carbon must have 4 single bonds. This idea of primary, secondary, and tertiary does not extend to, so let's put a tick mark, say carbon must have 4 bonds, right? So it cannot extend to a carbon containing at least 1 double bond or a triple bond and a single bond. Okay, why is it? I'll explain in just a second. Okay, we must know to, and also you see I said carbon bonding. I didn't just say bonding can be primary, secondary, or tertiary. I said carbon bonding, which means you have to determine whether that carbon is primary, secondary, or tertiary with only respect to the carbon, not with respect to what is attached to it. Even though hydrogen is a component we're looking for, we are only looking for the element carbon. That's the only element we're focusing on when we're deciding whether that carbon is primary, secondary, or tertiary. So what is primary? If a carbon contains minimum 2 hydrogens, not minimum, it must contain 2 hydrogens, and will only contain 2 hydrogens, and then the other 2 bonds could be anything. Okay, for instance, it could be part of the chain, but then that carbon itself, this is what I'm focusing on right now, right? This is exactly what I'm focusing on. That carbon contains 2 hydrogens, then that's a primary carbon. If a carbon contains only 1 hydrogen, and the remaining 3 could be anything, then that's a secondary carbon. Okay, the idea of hydrogen is the key. If a carbon contains 4 bonds and none of them are hydrogens, no hydrogens, then that's a tertiary carbon. Okay, so let's go ahead, and typically I've given 3 examples here. Let's dissect the carbons. So typically when there's a bend and nothing coming out of that bend, that's primary. Think about it. You know, if I redraw this molecule, it will look like this, right? You might wonder, hey, what about the one with the 3 hydrogens? Well, that's called metal, and it usually doesn't serve any purpose for stability other than it's called metal. So this is a metal, which we don't need, which we already know, which is not what we're interested in. So this is how we started, and this is how we moved into line structures, right? So typically, when there's a bend and nothing coming out of it, what I mean by nothing coming out of it is a substituent, right? So this carbon contains 2 hydrogens, right? Now again, you cannot forget all the basics we have learned. So this is a primary carbon. So is this. This carbon contains 2 hydrogens. Now don't get fixated. Hey, do I need to write the 2 hydrogens above or below? Those things don't really matter at this point. We're only trying to identify whether that carbon is primary, secondary, or tertiary. This is primary, by the way. And this is also 2 hydrogens. So typically when there's a bend, it's primary. Okay. And this is methyl. So the terminal is always methyl. Okay, this is methyl, which we're not interested in at this point. And let's go continue further. Again, the ends are methyl, so we're not worried about that. This is methyl. And so is this. Otherwise, when there's a bend, we know that's primary, right? I just explained that. The bends are primary because they each contain 2 hydrogens. Now this, however, this carbon contains 1, 2, 3 bonds, which means the 4th bond by default is hydrogen. So this is a secondary carbon. And that's it. Let's keep going. So this would be methyl. Again, this is primary. This is primary because there's a bend, and the bend doesn't have any substituent. This is also primary. This is methyl. What about this? This carbon contains 1, 2 bonds. The 3rd and the 4th also happen to be methyl, right? So this carbon has no more bonds left for it to be hydrogen. And this is a perfect candidate for a tertiary. Remember, I said a carbon containing 4 bonds and neither of them have a hydrogen attached to it, then that's a tertiary. Now, this is something you may want to know if you plan to take any professional exam is, what is a stability in terms of the carbon? Carbon stability. This is something you may have to know for my class and probably also have to know it for outside of my class. The carbon in the methyl is the least stable, followed by primary, followed by secondary, followed by tertiary. Why is that the case? We're going to learn it as we move further. For now, let's just understand that the tertiary is the most stable carbon and the methyl is the least stable. We will learn why that's the case as we move forward. But for now, I think this idea of least to more stable fits this occasion. So there is no primary, secondary, tertiary when it comes to carbon containing double bonds. But if the carbon does contain all single bonds, only then we can even talk about primary, secondary, and tertiary. And that's all I really want to say on this particular concept, because we're going to bring the idea of primary, secondary, and tertiary repeatedly throughout the organic chemical reactions that we are going to learn. So stay tuned for the actual chemical reactions themselves.